Thank you very much for the kind introduction and the chance to speak at this event. And with that, welcome to my presentation on the use of DoIP in future vehicle architectures. As my video editing skills were not quite up to the task, I wanted to give you a quick glimpse of the speaker at the beginning, and I will see you later for questions. Let's start with a little bit of history, as the history of diagnostics over Ethernet and IP starts before it actually became the name of the ISO 13400 document. It started specifically with a BMW project around 2005 that went into serious production by 2008. The idea behind this project was to speed up the flash process, particularly to those few high-volume update ECUs like head unit and rear seat entertainment. Connecting those to CAN and doing the software update over CAN was just taking way too long and was very unreliable due to the problems with CAN-TP that we all know about. So the idea was to actually switch from the application session to the bootloader session, and at the same time switch between a CAN connection and a layer 2 Ethernet connection. The session descriptions that I'm using here are obviously derived from ISO 14229. So the idea was that Ethernet was actually only used for the flash update, and all regular communication while the vehicle was running, and also the normal diagnostics for error codes and the likes were done over CAN. And since these were only very few ECUs, the additional effort of having 2 connections to this ECU was not considered a problem. As soon as, however, the number of ECUs increased, obviously there was a desire to have ECUs connected to Ethernet only. And this is when the 2 VLAN concept was born, where basically still a gateway was involved in order to do regular diagnostics. But this gateway would now transfer information from one Ethernet link that came from the OBD connector onto the internal VLAN. And when the switch over to the bootloader application happened, then actually was there a direct connection via layer 2 to the tester, so flash data could flow without going through a gateway from the tester directly to the ECU. So the ECU was completely independent at that stage from the rest of the vehicle. Unfortunately, this second step of the 2 VLAN process actually only came to life after ISO 13400 was published. And so the goals for ISO 13400 were still derived from the initial approach. And this initial approach was particularly focused in removing the gateway while updating the software, and thereby decentralizing the communication between the ECU and the tester. Again, with the goal to reduce the update time for the whole vehicle. Now, another advantage that came along with this was that if you want to do a connection to CAN to the vehicle, you always need some sort of tester device sitting next to each vehicle. This is obviously in a larger workshop or in a development system or even in a plant situation, this is not very advantageous. It'd be much easier if I could just connect my OBD connector with an RJ45 block into the network of whatever building I'm in, and then I can actually access that vehicle from some remote host and update the software of multiple vehicles without having to have a box sitting next to them. Actually, the advantage of IP was also that this access would work all across the world. So actually the tester might be sitting in Munich and the vehicles might be sitting in China or in South Africa. While this was all well and good, we still wanted to make sure that the direct connection of a laptop when you were out in the street, in the parking lot, doing some testing, that was still possible with just a direct connection without the infrastructure in between. Did this concept really work? Well, to be quite honest, there were quite a few issues that had not been looked at in detail when this was actually developed. As soon as the number of Ethernet ECUs rose within the car, we realized quickly that the load on the DHCP servers, especially in an assembly plant, actually was really, really high. And these DHCP servers were not made to respond in a very fast fashion that was required for what we envision for an assembly line process. On the other hand, while ISO 13400 tried to optimize the auto IP timings on the ECU side, there was still a problem that on a laptop or on a PC, DHCP actually starts first. And therefore, this concept of connecting the laptop to the car was always hindered by this initial startup process of DHCP and auto IP. Once the connection was established, it was still rather difficult to hold up the connection between the ECU, which was then associated to a single UDS address, the TCP session, and here we will have to talk also about ASUN MCD 3D, the IP address, and actually the vehicle that the ECU belonged to. And so what happened, people created these removable gateways, I will call them, these intermediate boxes that I'm showing to the right, which were holding things together because the decentralization that was introduced in ISO 13400 was giving them quite some problems. Another issue that we will be looking towards the end of the talk is safety and security, as with the introduction of software over the air updates and OBD dongles, the access possibilities to the vehicle became a lot larger than they were when ISO 13400 was devised. So let's start with some addressing issues, and we will start with those at the beginning, at the top of the ISO OSI stack, with the UDS-Server discovery. And you will see in the document that actually there is a vehicle announcement message. And this vehicle announcement message is supposed to be sent 3 times at the start of the ECU, meaning that you receive a message load of 3 times the number of vehicles, that times the number of ECUs within about 1.5 seconds when the whole system starts up. Now, for the laptop on the left, that may be a semi-useful feature. Also, one can question why you need to do this 3 times for every ECU. But in a setup where the tester is behind a router that obviously does not forward broadcast messages, these messages are all just wasted, and there is still a need to have some other discovery method. Furthermore, this whole discovery obviously depends on the IP address assignment process, and we will go to that next. The IP address assignment, as I mentioned before, was based either on the DHCP if we assumed to have an infrastructure, or on auto IP if we assumed that there was a laptop directly connected to the vehicle. Unfortunately, it is not known in the system which of the 2 cases is actually currently prevalent. And so we either have a chance of completely overloading DHCP servers with all the n times n number of vehicles times number of ECUs requests that are hitting this TCP server, DHCP server once the vehicles are connected. Or on the other hand, on the laptop, the DHCP starts before the auto IP process And while ISO 13400 has optimized the auto IP settings for ECUs, it could not optimize the settings for laptops. ISO 13400 also leaves open the question of whether to use IPv4 or IPv6. And technically, if you read through the document, you might come to a conclusion that ECUs might have to support both, which seems highly inefficient. So the IP address assignment process as currently defined is slow, and we have seen a lot of unintended consequences in terms of timeouts, and we will get to the security issues in a later slide. Another problem of the addressing space that we saw comes at layer 2. In 2014, Don Panel gave a talk and said that by 2020, he was assuming that each vehicle had between 50 and 150 ECUs that were reachable via Ethernet. Now, I think Don was a little bit ahead of the time, but maybe he is right in 5 or 10 years. Anyway, if we look at the globally unique MAC address space, we are definitely in a scarce situation. There has been a change in the assignment process of these addresses. And if we consider, like I mentioned before, that we're moving to a software update over the air, then actually this situation of having to connect the vehicle via this cable that we saw before to an unknown network, this will actually reduce. And so there is a valid question whether the concept of having layer 2 access to the vehicle is not actually wasting MAC address IP space, and whether we really need all of those addresses to go into vehicles. While this is all discussion about the external network, there is also, of course, a question: how does this all interoperate with vehicle internal communication? And as you saw before, the vehicle internal communication, when all of this was started, was actually assumed to happen over CAN. It was not assumed to work over Ethernet. So something like vehicle internal gateways were actually not really considered. If you look at the vehicle announcement message, it announces a single UDS address to be associated with a single IP address. So if you have a DoIP to CAN gateway and you would want to announce the UDS addresses of your CAN nodes as they become available, you would have to be sending a vehicle announcement message per CAN node. That is obviously a very inefficient way to do things. This is made even worse by the fact that a lot of people are moving away from using UDS addresses as box addresses, but actually people want to have a finer granularity in diagnostics, and they would like to actually address functionalities within larger, integrated, more complex ECUs. And so we're likely to actually see an increase in UDS addresses that are being used within the vehicle. But this will also mean that we need more vehicle announcement messages unless we want to have a secondary protocol to help us discover these UDS addresses and how they are reachable. So I think we can learn from this that we definitely need something more like a service discovery system than a box discovery system. The second point that was not really considered when ISO 13400 was created was the internal tester. Now, in the latest revision, it is deemed as optional, but I don't think that is actually quite accurate, as we still need to support the OBD CAN tester connection via a gateway, which actually turns for an Ethernet-only ECU that gateway into a de facto internal tester, which is now actually a requirement and not an optional feature. ISO 13400 speaks about static IP address configuration to be possible for these scenarios where internal communication is required, but it does not go into details and it does not describe the switchover or the requirements on the tester or on the ECU side to actually support such a dual IP system and what this means for the whole process of flash updating and the process of doing diagnostics. On the other hand, ISO 13400 has a concept of trying to keep the tester address unique, which is required because at UDS level, we can only address one tester address. And if we have two testers connected with the same address, we might potentially run into a problem of how to assign them to certain connections. This led to the Alive check, which for something like a gateway today is not really a good thing, as if you transport diagnostics data over one TCP connection to multiple ECUs behind a gateway, and then your Alive check for one tester fails, you are breaking up the connection for all those ECUs. So we need to go looking into the TCP connection handling that DoIP gives us. And here we see that a lot of error cases in DoIP are actually handled by way of breaking down the connection. But even worse than that, we need to be able to break down this connection for an ECU reset. While we do a flash update, we usually have multiple resets of the ECU, and we need to be able to reconnect to that ECU, and we need to do that across the mode switch that I showed you in a very early slide, and we need to do this quickly and reliably. Now, this becomes even worse if we have internal gateways that actually need to be able to do the switch over for ECUs that might go through resets separately. But we also need to do this for Ethernet ECUs that are behind switches. So we have a certain dependency on the topology of the whole system. And if we run a switch ECU through a reset and there is still a flash process going on for an ECU connected behind that, then we might run into a problem. Getting back to what I said at the beginning, the DoIP error handling is definitely relying on wanting to tear down the connection once there is a serious problem happening. Now, again, this becomes very tricky for gateways where we are now tearing down the connection because of a problem with a single ECU. Especially in systems like classic AUTOSAR, where we have a middleware environment, we also found it very difficult to keep control and knowledge over the network resources and being able to tear down and reset up this kind of connectivity over TCP. While TCP was chosen at the time as the layer 4 protocol because we wanted to transport flash data reliably across the internet, I told you about the Munich, South Africa case before, the TCP timeouts and the UDS timeouts in general do not fit together very well. Furthermore, when we look at the gateway problem, TCP has very limited hardware support, and therefore this TCP to CAN and backwards gateway is always limited by software efficiency. TCP also has quite an elaborate resource usage, and we need quite a bit of session handling. If you've ever seen the state machine of TCP, that can actually get quite tricky, especially if the connection is torn down unexpectedly. So while TCP is still, I think, the best way to deliver data to the vehicle, it may not be the best way to actually distribute data inside the vehicle. And now keep in mind, we are moving to a software over the air update scenario. So we might have to think about how do we transport flash update data within a vehicle. Do we need to look at systems like IEEE 1722.1, where firmware updates to AVB devices is described? Do we need to look at systems like TFTP, where we have a stop and wait system in order to deliver data slowly but reliably? But in the software over the air update scenario, maybe we do have a little more time and different requirements than this scenario in a workshop, where we are quite in a rush to get the data into the ECU. And with that, we get to our last topic, and that is security, which obviously starts at the edge node. And like I mentioned at the beginning, this whole discovery process and this whole integration into the outside network that the edge node is supposed to provide to this whole system actually opens up quite a few security holes, because we already need to open up the vehicle before we actually really know who is trying to connect to us. And if we don't open up this far at the beginning, then we need further elements, further protocols in order to allow access to the vehicle, which still, if you look at ISO 13400, has a risk of a once open problem. So I think we definitely need a smarter communication concept at that edge node to allow the setup, for example, of hardware filters, and be able to not have for each ECU to worry about its own security, as is suggested by the TLS approach in the current ISO 13400 document. The last topic that I want to cover is actually the integration of new Ethernet-based ECUs into a vehicle, for example, at a repair shop. And also the question is, how can we trust an ECU that is mounted sort of to the outside of the vehicle, that is easily accessible? How can we trust this ECU that there is no man in the middle that would actually benefit from a once open, where the ECU grants itself access to the vehicle and then somebody can take over that access? Systems like 802.1x and 802.1ae are known in the wider Ethernet world, but I think they need adaptation for the use in the vehicle to be fast enough and to actually fit with the computational requirements that we see within the car. And with that, I want to summarize with a conclusion. The idea of the decentralized per ECU diagnostics flash access was a very good thing back in the days in order to speed up the flash process, but I think it has kind of outlived itself by looking at what do we do for software over the air updates, and how has the whole communication concept within the vehicle changed. So we need to look more into the internal diagnostics than is currently the case. We also should have taken a closer look at the MCD3D standard, which had a huge impact on the process of how to do the update. But we also need to acknowledge that going back to a software-only solution is probably very inefficient. So I would call for a smarter hardware-based solution that allows us to bring back the context of the vehicle together with the ECUs and look at this together with the tester and the software over the air as one system and not as singular solutions. And with that, I want to thank you for your attention, and I'm looking forward to your questions.